Hi. As mentioned yesterday in the video, we talked a little bit about something called difference of two squares, or dots. That is the special factoring that we're going to be talking about today. As I mentioned yesterday, that each day this week we're going to be talking about a different factoring method. So, difference of two squares. Quadratics of the form a squared minus b squared are called a difference of two squares and can be factored using the formula a squared minus b squared is equal to a plus b times a minus b. We started to get into that a little bit yesterday. They're giving us some examples and asking us to factor completely. So essentially what's happening is when you're given difference of two squares, when you're given one squared and then subtracted by another squared, you're asking yourself what your square root is. That's what's happening over here. Another way we can write this formula is a squared minus b squared is equal to the square root of a squared plus the square root of b squared times the square root of a squared minus the square root of b squared. And that's how we get it into the form that you see up here. Because the square root of a squared is just a, the square root of b squared is just b. So that's why it becomes a plus b times a minus b. If we take a look, for a, we have x squared and 9. We have 1 squared minus another squared. So we can automatically know that this is going to be some term plus another term times some term minus another term. We have to find out what is the square root of x squared. The answer to that is x. The square root of x squared is x. That goes in the front of each bubble. Now we have to ask ourselves, what is the square root of 9? Square root of 9 is 3. So that's what's going to go in the back of each bubble. We have to ask ourselves, is there anything else we can do to factor? The first thing we should have looked for is greatest common factor, but the only thing that these two terms share is a 1. So there is no greatest common factor. Once we do our dots, we can't factor anything in here. This isn't a square, and this isn't a square. So we can't factor anything in there. So A is done. Now we're going to look at B. Is there any greatest common factor in B? Our answer is no. So now let's take a look what's happening. We have one square and another square, and they're being subtracted from one another. So this is difference of two squares. So again, since we know it's difference of two squares, we can say it's plus and minus. We just have to find out what fills in our parentheses. So what is the square root of x squared? The answer is x. What is the square root of 16? The answer is 4. Can we do anything else with it? We don't have any greatest common factor, and we can't do any other factoring method. Here, we don't have any greatest common factor, and we don't have any other factoring method. If this was a square up here, then we would have another difference of two squares. But because we don't have a square up here, it's not, and we're done. Now let's take a look at C. We always look for greatest common factor first, and this is why. If we don't pull out the greatest common factor here, then we won't see our difference of two squares. Because 2 is not a perfect square, and 8 is not a perfect square. So, we know that the greatest common factor here is 2, because 2 goes into 2, and 2 goes into 8. So this is going to be 2. Remember, we have to put it in front of the parentheses. When we divide by 2, that's just going to leave us with x squared. Over here, when we divide by 2, that's just going to leave us with negative 4. Now we have to ask ourselves, are we done? They're asking us to factor completely. And our answer is no, because we have x squared, which is a square, and 4, which is a square, 2 times 2. So this is a difference of 2 squares. That's what I was talking about before if we had a square up here. So this is going to end up being, we still have to keep our 2 outside the parentheses. But now we're going to have 2 sets of parentheses. We're going to have 1 plus and 1 minus. We have to figure out what is the square root of x squared. It's going to be x. What's the square root of 4? It's going to be 2. Now we have to look at it. Is it fully factored? In this case, yes. Good. And they walked us through, see, here. And you can see they're saying, since both terms divide evenly by 2, we factor out the 2. That's exactly what we did. The resulting quadratic is a difference of 2 squares. Therefore, we can factor further. That's exactly what we just did. A sum of 2 squares cannot be factored. It is considered to be prime. What that means is if we have, let's say, x squared plus 4, this is considered a sum of 2 squares, and we can't factor it using real numbers. This can only be factored using imaginary numbers, but we don't need to worry about that. We can say that it cannot be factored using real numbers and considered to be prime. So that's a little bit with our dots. Our textbook has factoring difference of 2 squares. They're giving us some problems. I'm going to go through this page, and then I'm going to go through this page a little bit. What I want you to do is I want you to work on 1 through 15. So I'm going to go through a little bit more of dots, and I want you to answer 1 through 15. I'll post this page to Google Classroom. So let's take a look. We have factoring the difference of 2 squares. They're showing us model problems. Multiply and show your work. What they're actually doing is they are working from our answer to our dots to show us what it would have been in. They're showing you the pattern of how to recognize if you would have had dots. See, you have m squared minus n squared. They're just multiplying. They're using their distributive property or the box method. That's what they're doing there. So that doesn't help us with factoring it, but that helps us with realizing what's happening and why it breaks up that way. What you can see is when you multiply it, your middle term actually cancels out. And that's why you're just left with 1 square subtracting another square. So what I'm actually going to do is I'm going to actually work backwards to show you the factoring. Because the questions on the page aren't asking about multiplying. They're asking which ones are factored correctly or which ones are factored incorrectly. Except for 5 through 14. They are asking about the product. So I'm going to go through a little bit of working backwards. And then so we're equipped to deal with 5 through 14, I'm going to show you the pattern. Actually, I'll show you the pattern now. So that way we get it covered with. So if you have anything that is A plus B times A minus B, right? That's what our dots would have worked out into when we factor it. When you multiply it, remember that we have to do our FOIL method. First, outer, inner, last. So our first, we have a times a, which is going to give us a squared. Then we have a times negative b, which is going to give us negative ab. B times a, which is going to give us plus ab. And then b times negative b, which is going to end up giving us negative b squared. That's going to happen, this pattern, whenever you have a setup like this, where you have the same number in the first part of your parentheses, the same number in your last part of your parentheses, and the only thing that is changed is your middle term. These are actually special. They are called conjugates of one another because they're exactly the same except for your middle term. With that being said, we can see here that we have minus AB and plus AB. They're going to cancel each other out, and we're going to be left with A squared minus B squared. So when it comes to 5 through 14, and they're asking you to find each product, as long as they're conjugates of one another, as long as you have exactly the same thing in the first part of each parenthesis, exactly the same thing in the back of each parenthesis, and the only thing that's different is the sign, you can follow this pattern. Just take your A and square it. Just take your B and square it. And then you'll have A squared minus B squared. And that would be your answer for your product. A squared minus B squared. Where A is the first term in your parenthesis and B is the second term in your parenthesis. So that hopefully should have made 5 through 14 a little bit easier. If you have any questions on that, please let me know, but this is basically what we need to know for 5 through 14. With the finding out if it's factored correctly, that's like we were doing over here. That's going the opposite way. That's knowing that if you have A squared minus B squared, then that's the same thing as A plus B times A minus B. So for where you actually have to factor, you're going to be going in reverse. Take your first term, take the square root of it, put it in the front of each bubble. Take your second term, take the square root of it, put it in the back of each bubble. Make one bubble positive, one bubble negative. And that's how you can factor it. So let's go through a few examples. If we see here, notice they're giving that same example that I did here, the same basic one, where you have A squared minus B squared. They were showing that longer one over here. They're showing you the square root of A plus the square root of B squared. The square root of A squared plus the square root of B squared times the square root of A squared minus the square root of B squared, which will come down to A plus B times A minus C. So basically they're telling you take the square root of the first term, square root of 16 is 4, the square root of x squared is just x. So that's how we got 4x and 4x. The square root of 25 is 5. That's how we got 5 and 5. So then we just make one bubble positive, one bubble negative, and that's how we factor it. You can check to make sure you have factored correctly by re-multiplying in. That is a way that you could do it. If you re-multiply by using your distributive or the box, and you get back to where you started, then you know that you factored it fine. So that's another way of doing the check. I mean, it's a little bit longer. You can check to see with these, if they're factoring them, if when you multiply it back together, if it gives you what you started with. Like, for example, here with a, if you multiply in, 10 times negative 10 is negative 100. This is going to end up giving us negative 100 x squared y squared. That's not what we started with. So we know that a is not the answer for 1. So we know that the answer for 1 is either B, C, or D. And we just have to make sure that when we multiply it back together, it's the same. Or we can use the shortcut formula. If we have a squared minus b squared, we know that it's just a plus b times a minus b, where a is the square root of a squared and b is the square root of b squared. So over here, take the square root of x squared, y squared. What do you get? Take the square root of 100. What do you get? You know that it has to be, since we have a square minus a square, difference of two squares, it's not going to be b, because this is not our formula, which means it's either C or D. And we can see they're almost the same. It's just we have minus minus plus minus. And with our difference of two squares, our formula is make sure that the signs are different. So that's for this one, the answer for this one is D. Difference of two squares is factored into D. So I want you to work on 2, 3, 4, 5 through 14. 15 we already did the answer. If you found the shortcut for these exercises, what is it and why does it work? We showed that over here. This was the shortcut, that instead of remultiplying everything out, just take the first term, square it, take the second term, square it, and subtract the two. So that's the shortcut for 15. Again, I'm going to post this page to Google Classroom. If anyone has any questions, please let me know. Thank you.